2, let's take a look. We're doing the same exact idea. We're going to start out with f, the circle of g of x. And we'll start by just switching the notation and replacing the circle with the parentheses. So that gives us f of g of x. And we'll start inside our set of parentheses with our g of x, and we'll make our swap. Starting our way inside and working our way out. And so we're going to replace our g with what it is, which is the square root of 2x minus 1. And what this means that we're going to do is we're going to go to our function f, and we're going to replace the x with what's inside. So we'll replace our x with what's inside. So let's see what that means we will have. So our f function has 8x, so we're going to replace that x with what was inside, the square root of 2x minus 1, and then they had a minus 9 that should be on the outside. Now, I could put parentheses around the square root that we plugged in, but you don't have to. The reason why you don't have to with this one is because it's understood, because it's already being held together. All of everything's being held together by that square root, that you don't need parentheses. So it's kind of like overkill if you actually keep them. So this can't be simplified at all because what's inside and what's outside can't be mixed and matched. And that's okay. However, the domain we can do something about. With the domain, we do have an issue on this one. It's not that we have an even root, because we don't. This time our problem is that we've run into an issue because we do have an even root, we don't have a fraction. So our problem is we don't have a fraction, we have an even root because we've got a square root here. So the question is, how do we find its domain? Well, the problem with a root is that the inside needs to be not negative because we don't want to end up with i's. So whatever is inside the root, if you've got an even root, whatever's inside needs to be greater than or equal to 0. Well, what's inside of this root is a 2x minus 1. So let's make sure that that inside piece does end up being, the 2x minus 1 does end up being greater than or equal to 0. So what we'll do is we'll solve this like you would a normal inequality by adding 1 to both sides. And that will give us a 2x is greater than or equal to 1. Then we'll divide both sides by 2. And let's see, that will give us, an x is greater than or equal to 1/2. The problem with this is technically our domain, is that we just can't leave it like this. Our domain needs to be in what's called interval notation, which means you may want to go ahead and draw out a picture of what this looks like. So drawing this out on a number line, here's our value at 1/2. And because it's got a greater than or equal to symbol, it means that we're going to have a bracket. The greater than means we're going to be pointing to the right. So we'll have a bracket because of the equal to, and it's pointing off to the right. That means our official final answer for our domain is going to be however we read this graph from left to right. Well, from left to right, the graph starts at a bracket at 1/2 and continues off to infinity, because it's continuing off forever. Remember that infinity always uses a parenthesis, and that's going to be our final answer for our domain. Now let's try part B, which is very similar, same idea. It's just we're going to look at g of f of x. And again, we'll start off the same way by replacing the circle notation with the parentheses. So that will look like g of f of x. So what we'll do first is, just like the last one, is we will swap out the f of x, the inside part, first. So what that will look like is we'll have now g of, well, f of x was 8x minus 9. And what this is telling me to do is now plug this in to my g of x function wherever there's an x. Well, there's an x, but it's inside of the root. So we'll replace that x with what's inside. So what it'll look like, to start with at least, is our square root of 2. Then our x is going to get replaced by the 8x minus 9. Don't forget your parentheses because everything's all jumbled up together. And then there was a minus, and then there was a minus 1 underneath that root. Well, there is some math I can do here to simplify this. What I can do to simplify this is I have a 2 and I've got a set of parentheses I can distribute. Well, if I distribute the 2, I'm going to get a 16x minus 18. I still have, be careful, the minus 1 underneath there. So I can go ahead and combine my like terms because I have a negative 18 and a negative 1 under there. So I'll have my 16x, and then my negative 18 and my negative 1 will become negative 19. And that's as far as I can go for simplifying it, so that will be my actual function. However, I still need to find its domain. And just like the last one, I have an even root, which is my problem. I do not have a fraction, just an even root. So my fraction's not a problem. I have an even root on this one. And just like the last one is whatever, if you have an even root, whatever's on the inside needs to not be giving us i's, so it needs to be greater than or equal to 0. That's not going to change. Except for what's inside this one is a little bit different. It's a little bit different. It's a 16x minus 19. So that's your inside part that needs to be greater than or equal to 0. So we'll take our 16x minus 19 and make sure that ends up being greater than or equal to 0. So how do we solve this? We're going to add 19 to both sides. And that will give me a 16x is greater than or equal to 19. And then we'll divide both sides by 16. And that will give me, let's see, x is greater than or equal to 19 over 16. And that's really all I can do because 19 over 16 cannot be reduced. So then I need to work on my interval notation because I cannot leave my domain like this. Interval notation means I should probably draw out a graph. You don't have to, but it can't hurt. Is we've got our 19 over 16. And it says greater than 19 over 16, so it's pointing to the right, and the equal to means we'll have a bracket. So that means our domain is, if I want to read this graph from left to right, it would look like the following. It would start with a bracket at 19 over 16 and would continue on because of the arrow towards infinity with a parentheses. Now, I know a lot of students will say, oh, is it always going to be a bracket at the first number and then off to infinity? No. I know it always starts out as a greater than or equal to 0, but there are things when you're solving an inequality that will flip the direction. Remember, if you multiply or divide both sides of an inequality by a negative, it will flip the direction the inequality is pointing. And that would switch the answer dramatically. So kind of keep that in mind.